Assalamualaikum and hello everyone. Now I already explained to you the positions of the new incoming electrophile. Where should be the positions of that electrophile? So let's move on to the reactions of methylbenzene. Now first one, this is the structure of methylbenzene where the CH3 is methyl and then it is attached to your benzene. So you call this structure methylbenzene. Now here, since CH3, here this one CH3 is an electron donating group. Remember the previous video that I show. Okay, so since CH3 is an electron donating group, incoming electrophile will attack at the positions of 2 or positions of 4, or can be the combinations of these two. Okay, both of these two will be there with certain percentage. Okay, now due to the presence of CH3 group, it activates the benzene ring because CH3 it donates the electron to the benzene ring. So now your benzene ring is even richer with electrons. Okay, that's why the reaction will be more reactive compared to just a benzene. Okay, now here for methylbenzene, there are 3 reactions that it undergoes. The first one is the same thing, electrophilic substitution, the same reaction like benzene. Okay, and then the second one, we have a free radical substitution. This one is on the alkyl side chain. It means that on the CH3 itself here. Okay, and the last one is the oxidation, also on the CH3 itself, except for this first one, electrophilic substitution, it will happen in the ring here. Okay, so let's take a look on the first one. I'm just gonna briefly go through this because this one I'll send you the worksheets on it. Okay, now halogenations, you can see that the reagent will be chlorine, and then you can see that the condition is the same like benzene. You have the catalyst AlCl3, and also it just need a room temperature. Now if you do realize here, I only use one of the methyl benzene, okay, and react with 2 chlorine. Reason why? Because you can have a position, remember the position, it can be on the second or it can be on the 4th, because CH3 here is an electron donating group. So the new positions of your electrophile will be on the 2nd or it can be on the 4th. Okay, so you can write down the equation like this, or you can do it separately. Like one of the methyl benzene react with 1 chlorine to give you the 2nd position, and then one of the HCl. Or you can have the CH3 with another mole of chlorine, 1 mole of chlorine, and it gives you the 4th position, 4-chloromethylbenzene, and also side product another HCl. But this one, I just want to show to combine that for each of this, it can separate into 2. Either on the 2nd position or it can be on the 4th position. Okay, now next one, we have halogenation as well. Okay, so here it is, we are using bromine. Again, anhydrous FeBr3 catalyst, the same thing like benzene. And same thing, instead of chlorine here, now you have bromine here. Okay, but if you do realize, the position is still on the 2nd carbon and the other one is on the 4th carbon, and your side product will be HBr. Okay, now maybe you will ask me, teacher, why don't you put 2 of the methylbenzene here? Because remember, this CH3, it will get separated only, like for example, only you have 60% of this and then 40% of the other. Okay, out of that 100% product that you get. That's why I don't put 2 moles of CH3. This one I want to show that it can give you position 2, it can give you another position 4 from same methylbenzene that you have. Okay, now next one. Okay, this is the same thing, still under electrophilic substitution. That's the mechanism as well. Okay, so we have nitration, same thing. You see here, HNO3 concentrated, and then also concentrated sulfuric acid. How to get the NO2? I already show you under benzene. Now remember, since methylbenzene is more reactive than benzene, you do realize now the temperature is less compared to benzene. Benzene have 55 degree Celsius, but for this one we have only 30 degree Celsius. Okay, so again same thing, the NO2 will attach at the second, and it can also be on the fourth. So you call this 2-nitromethylbenzene. This one you call 4-nitromethylbenzene, and the side product is water. Now what happened if I increase the temperature? Instead of 30, now I increase it to 100 degrees Celsius. It means that I'm using a higher temperature. So what happened here is that all of these 2, 4 and 6 position will be occupied by nitro. Okay, nitronium ion, the NO2. Reason why here, remember, the 2 and the 6 position in substituent arenes are equivalent. Reason why is because if you count it clockwise, this is the second position here. But if you count it anti-clockwise, this is your second position there. That's why all of this 2, 4 and 6 will be occupied. So it will looks like this. What do you call this? The main parents, the chain is methylbenzene. So you will have 2, 4, 6 trinitro, because you have 3 of the same group, the nitro, trinitro-methylbenzene. Or the famous name for this is the trinitrotoluene. Maybe you familiar with the TNT. Okay, the one that you use to make explosion. It is a pale yellow solid. Okay, so I'm just make sure that I have 3 of the HNO3 because it will provide me with 3 of the NO2 and NO2, and then also it will give me 3 moles of the water. Make sure you have to balance the equation. Okay, now we have another one, number 4, alkylation. So you will have halogenoalkane reacting with your methylbenzene. Same thing, the CH2, CH3, the alkyl will be attached at the second. It can be also attached at the fourth position. And your side product will be HCl. Cl from here, and then the hydrogen that you replace from the second or from the fourth positions of the benzene. And then what you call this, it will be 2, because it's on the second position, 2-ethyl. This is what you call ethyl because 2 carbon, 2-ethyl, and then the parents chain is the methylbenzene. And then this one, since the ethyl is on the fourth position, you call it 4-ethyl-methylbenzene, and the side product will be HCl. Okay, just make sure that, remember, if you want to do one equation only, 1 methyl with 1 halogenoalkane, so it will give you 1 of this and 1 of the HCl. So just make sure you balance your equation. This is to show you again, it can be on the second, it can be on the fourth. That's why I'm using the overall equation here. Okay, now the last one is the acylation. So acylation, you are using the CH3COCl. Okay, and then again you will have CH3 methylbenzene here. Now here it will be COCH3, that will be on the second position, or it can be on the fourth position as well. Reason again, because CH3 is an electron donating, so the new electrophile will be attached on the second, or it can be attached at the fourth. So what do you name this? Now between methylbenzene, okay, and then phenylethanone, phenylethanone should be your main characteristic of this compound. Okay, so the reaction is more towards this COCH3 thing. So this now will be your parents chain. That's why here the parents chain will be phenylethanone. You call the benzene now phenyl. Okay, ethanone because you have the COCH3 here. And then now your CH3 will be your substituent. Okay, so it will be 2-methyl phenylethanone, and this one will be 4-methyl phenylethanone because the ethanone is the first carbon, 2, 3, 4. So it will be 4-methyl phenylethanone. For this one, the ethanone here will be the first carbon, and then this will be second. Remember, lowest numbering. You don't go say that 6 because you go 1, 2, 3, 4, 5, 6. That is wrong. Okay. Now next one, we already done with the first reaction, which is electrophilic substitution. Next one is the free radical substitution. If you do realize, we have go through this from your AS knowledge, okay, which is under alkane. Okay, remember free radical substitution, it will attack at the alkyl. So it won't attack at your benzene. Reason why, even though you use chlorine, the same thing like this one, you use chlorine for halogenation. But the problem is, you look at the condition. For this one, the condition is using UV light. So what happened is that it won't attack at your benzene. Instead, it will attack at your alkyl. Okay, so CH3, you just replace one of the hydrogen with the chlorine. So now it will become CH2Cl. So what do you call this? It will be chloromethylbenzene. Okay, so again, chloromethylbenzene. And then next one, let's say for example, you keep on adding the chlorine so that you replace all the hydrogen in the methyl. Okay, so here it will be CCl3. It means that you already replace all the hydrogen in your methyl. So what do you call this? It will be tetrachloromethylbenzene. Okay, so this one will be plus 3HCl. Now next one, done with the free radical substitution, the last one is oxidation. Okay, now for the oxidation here, you have the methyl, it undergo oxidation. It will only attack at the CH3. It won't attack at your benzene. Okay, nothing happened to this benzene ring. The only thing happened is to the CH3 group. Okay, so for example here, the reagent you use is acidified potassium manganate or acidified potassium dichromate. Remember, the acidified comes from the dilute sulfuric acid. You cannot use HCl, you cannot use HNO3. Okay, condition will be reflux. So the first one, if you have alkyl group here, okay, it will be oxidized into carboxylic acid. So you call this benzoic acid. So again, CH3 here, it will become COOH. And there will be water. Now, why do I put 3 oxygen here? Because here there's no oxygen. But if you count on your product, there are 1, 2, and 3. Therefore, there are 3 oxygen. Okay. Now, what happened if, let's say, instead of having methylbenzene, you have ethylbenzene? So, what happened to the CH2, CH3? The same thing. No matter how long is your carbon here, it will only give you one carboxylic acid group. So you don't say that it's COOH and then another COOH. No. The remaining CH3, the remaining carbon here will become carbon dioxide. So you only will form benzoic acid. No matter how long is your alkyl chain here, it will only give you COOH. The rest will give you carbon dioxide. That's why here the remaining is one carbon there. That's why you only produce one CO2. Let's say I have propyl here, CH2, CH2, CH3. The remaining 2 will become 2 carbon dioxide. So now you count how many oxygen here. You have 1, 2, 3, 4 because there are 2 here. And then 5 and 6. That's why I put 6 oxidizing agent here. And you call this again benzoic acid. And if you do realize, if you have a longer carbon chain than the methyl, this one only 1, there is no carbon dioxide. But if you have more than 1, the rest, the remaining here, will give you carbon dioxide. Okay, so that's it for methylbenzene. So I hope that you can apply this one. Thank you.